for our second example of sketching tree functions, something slightly more complicated. So we've got 4 minus 2 sine 3x, and we are sketching that over a domain of negative pi on 2 out to 3 pi on 2. So what we're going to do here, so we've got an amplitude of 2, because that's what it is there. We have a midpoint, or an equilibrium point, or K, of 4. Now, because it's negative, our graph is flipped, or it's reflected in the x-axis. And our period, t, equals 2 pi over the coefficient of x, 3. So it's going to repeat itself every pi on 3. Now, to make life easier for ourselves, what we're going to do is, we've got 2 pi on 3 and 3 pi on 2, negative pi on 2. What we want to do, we want to sketch this based on common factors of pi on 2 and pi on 3. Something which is common to both of them is pi on 6. So we're going to use this pi on 6 to sketch or to highlight key points of the graph. So basically, this 4 is our starting point, and because our graph is inverted, it's a sine graph. Sine, as we know, normally starts at 0, works its way up, and then comes back down. This graph, though, is going to start at 4, and then it's going to work its way down, but it's only going to go down by 2, because that's our amplitude. That tells us how far away we are from the midpoint. It's going to go up then to 6, it's going to come down, and it's going to do that a number of times over the given domain. So what we'll do is we'll sketch that, and we'll make our domain and range, we'll make our domain fit it. So, like I said, we're going to start at 4, and we'll work our way down, up, down, up, and down. Now, for all these different points, like I said, so here we've got 0, and then we have a different colour, 2 pi on 3. Don't have to write it down there. 2 pi over 3. And then as we keep going, so now from there, what we can also do, we can start halving and working out exactly where we've got some of the points. So we know 2 pi on 3 is equivalent to 4 pi over 6. So from there, half of that ends up being 2 pi over 6. Half of that again is pi over 6. And this point here that we have is 3 pi over 6. So as we keep going to a different point on our graph, it keeps going up by multiples of pi on 6. So if this is 4 pi on 6, then this would be at 5 pi on 6. This is 6 pi on 6. Got a maximum at 7 pi on 6. Then we're here at 8 pi on 6. And then for the last one, we're at 9 pi on 6. Because 3 pi on 2, you multiply both the top and the bottom by 3. And then we end up with 9 pi over 6. So that shows what it's like on the positive part. We've also got to go back pi on 2. So to do that, we are looking for, we're looking to go back to 3 pi on 6. So what we'll do, we'll go off and we'll sketch that as well. So we'll start off. We know that we're going to reach a maximum, and we're going to come down. So based on that, we are at 0, and then at here, we're at negative pi over 6, a maximum of negative 2 pi over 6, and then it comes back down to negative 3 pi over 6. So rather than coming up with a, and I mean I've done these a number of times, rather than drawing your axes and then putting in different points, I say sketch the graph. Get an idea what the shape is going to be, and this will come with time, it'll come with practice, and then fill in the points as you go. For me, that works, and that's what I recommend that you do. Like I said, it'll take a bit of time, but draw the positive half, however many cycles you need to draw, and then go back and draw the negative half. Make sure it's symmetrical. Make sure you've got an even spacing between the periods so it actually looks like it's supposed to, and then your points will match up nicely.